Okay, hey everyone. So I'm gonna do a little bit of test review. I'm just gonna go through it so you can kind of use these videos to help yourselves out. The first one that I'm gonna do is gonna be all about notations and sets. So that was way back at the very beginning of Unit 1, so it's been a little bit. Notation, remember, is all the symbols. So can you write mathematically and can you write in plain English? And then we're gonna talk about sets and non-sets. So on this first part, this is just a review for you guys to kind of be able to write what each thing stands for. So if you ever see it written as an element or this belongs to, remember that symbol is that kind of like curly E. So that means element. There exists is that backwards E. So anytime you see there exists, that can be replaced with that symbol. For all, that A is important. For all and for every, that's the upside down A. So for all and for every. Such that has two symbols, so you can see it written either way. You can see it written as this colon, that means such that, or if you have this bar like that, that also means such that. Next one is implies. So implies is just going to be an arrow, or it can say that it maps to something. And then the next ones are all different types of sets. So you have like the set of natural numbers, integers, rationals, so on and so forth. So natural numbers is going to be that double bar N, like that. Your natural numbers are like your counting numbers. So 1, 2, 3, 4, so on and so forth. Next one is your integers. So that's this double bar Z. So it looks like that double bar Z. Your integers are include your negative numbers and your positive numbers. So -2, -1. It also includes 0, 1, 2, so on and so forth. The next one is your rational numbers. So rational is written as this double bar Q. So you're going to probably write it like that. Now, rational numbers, remember, anything that you can write as A over B, and A and B both have to be integers. So some of those can include like 1/2, that's a rational number. If you have like 0.1, that's a rational number because you could write it as 1/10. Rational number could also include just like a whole number. So if you have like the number 20, that's a rational number. Anything other than that. So then you have your irrational numbers. So to denote that something is an irrational number, it's still going to be this Q, but it's going to have this C exponent because that means the counter. All right. So it's the opposite of rational numbers. So you cannot write it as a fraction. That's going to be something like pi is irrational. Another one is Euler's number, which we're going to talk about later in the year. But that E is Euler's number. That's an irrational number. Or something like the square root of 2, because that's a non-repeating. You can't write that. Those are all examples of irrational numbers. Then you have your real numbers, which is going to be this double bar R. All right, and your real numbers are pretty much any number that you could ever think of. It can be irrational, rational, integers, natural numbers, all those combined to create your real numbers. The only thing that it doesn't involve is imaginary numbers, and that's where your complex gets in. So complex, we're going to write is this double bar C, and that's when you get into all your stuff with i's. So remember, I is equal to the square root of -1. So that's kind of what we're talking about when we talk about complex. Okay, so that is all of that. The next part is going to be, I'm going to do 2 examples of writing it. Now, when you're writing it, your answers can vary a little bit because there's different ways to write different things. So this is an example of one. Sometimes it can be a little bit different. Okay, so if I'm going to go through plain English and try to write it mathematically, I'm going to kind of go through and just plug in symbols wherever I can. Then I'm going to try to write it all together. So right off the bat, I see there exists. So there exists, I know I'm automatically thinking, okay, there exists. A negative number, so I'm going to have to do something with negatives. Y. Belonging to, so if I see belongs to, then I'm thinking that's an element of. the integers, remember the integers is that double bar z, such that I like to use the colon. Some people like to use the bar, doesn't matter. And then we have this equation y equals -10. Okay, so if I wanted to start to plug all that stuff together, I'm going to start with the there exists. And I'm going to find a way to write a negative number y that belongs to the integers. So if I say that y is an element of the integers negative. So it moves around it a little bit, but it's still hitting all those important things. And then we're going to say such that, and then if you're ever given an equation, that equation is just going to kind of come straight over. So that's how you would write that one. There's a couple different ways, but that's going to kind of be your basic. Okay, so now we're going to go and we're going to work the other way. So right off the bat, I see that upside down A. That means for all and for every. This is saying that W is greater than 1. And then we have W squared is greater than W. Sometimes you're going to have to add in filler words as you go, so it kind of makes sense. So this one, I would say for all W, and we're just going to write it out, that's greater than 1. That comma kind of says that something else is happening. So it's not technically one of the ones that we've talked about, but we can say for all W greater than 1, there is a W squared that is greater than W. So again, I kind of added some filler words in so that it reads really nicely. And you're going to probably want to add in a couple filler words so that it reads really nicely. But the big parts are that, like, I'm hitting my for all. I'm using my same variables. I know that this is a greater than symbol, so explaining that that's a greater than symbol. Just things like that are going to be what they're looking for. Do you know what those mathematical symbols mean, and can you put them in a sentence that makes sense? Okay. Next thing we're going to talk about is sets. So I'm hoping that on the test, sets are going to be the thing that like give you the points, okay? So it should be like a freebie question. So starting off with the definition, in order for it to be a set, it must be well-defined. That's really, really important. Well-defined. It has to have specific rules that it meets. There cannot be any ambiguity between it. So it cannot be vague at all. So if you look at this next one, which of the following is not a set? So if you look at A, the set of all past U.S. presidents, that is set in stone. You either were a president or you weren't a president. There's no like, well, they kind of were or this kind of was. So this is a set. Can't be that. Next one, the set of all short people at Steele High School. Okay, so that is vague because to me, short might be one thing and to you, short might mean another thing. Maybe I think that short's under 5'6" and you think that short is under 5 foot. So this is not well defined. So this one would not be a set. Just looking at C, the set of all even integers from 1 to 10, 2, 4, 6, 8, 10, all the way up to, or from 1 to 100, they're again, set in stone. It either is an even integer or it's not an even integer. There's no in between. So this one also would be a set. Okay, the last one is saying, how do you write the set of even integers in set notation? So if you want to write a set notation, that implies curly brackets. And if I'm going to write the even integers, I'm obviously not going to write out every single even integer that there is. So I need to apply a pattern, and then I can kind of show from there. So if I apply the pattern of, okay, even integers could be -4, -2, 0 is technically an even integer, 2, 4. I've started to establish a pattern. It can be negative, it can be positive. Now I just need to show that that pattern can continue. So if I show that that pattern can continue positively, and if I show that that pattern can continue negatively, the person that's reading that knows to continue on in both ways, and then I need to indicate that it's a set by putting this in curly brackets. So that was just kind of an example I wanted you guys to be able to see. Okay, so that is set 1, or this is the first part of unit 1. I hope this helped out. If you have any extra questions, make sure you guys are coming to tutoring. All right, bye.